Hello and welcome to SigmaXL video tutorials. In this video, I'll be covering ANOM Binomial Proportions one-way and Binomial Proportions two-way tools found in SigmaXL. ANOM Normal one and two-way have been covered in another video. We'll start this video by taking a look at ANOM Binomial Proportions one-way. The formula you're seeing on screen is based on the normal approximation to the binomial. So it requires sample sizes large enough that MP and MP-1 are greater than 5. SigmaXL automatically checks this and gives a warning message if the condition's not met. For this video, we'll be using a sample data set included with SigmaXL called ANOM examples. To open the sample data set, click SigmaXL, Help, Sample Data, and then find the file anomexamples.slxx. Click on the Test Scores Binomial Prop tab, which is standardized math test score data from 10 elementary schools. We are testing to see if there's a difference between schools, and we'll use alpha equals 0.01. Click SigmaXL, Graphical Tools, Analysis of Means, ANOM, ANOM Binomial Proportions one-way. Select Proficient, click Numeric Data Variable Y. Select Enrollment, click Subgroup Column or Size, select School, and click Optional Group Category X. Set alpha to 0.01. Clicking OK will provide the ANOM Binomial Proportions one-way chart. The resulting ANOM decision chart shows that 3 schools are performing at significantly low levels and 2 schools are performing at significantly high levels. As mentioned at the beginning of this video, SigmaXL automatically checks to see if the sample sizes are large enough for the normal approximation to the binomial to be valid. Here we see a warning advising us that sample sizes are too small to use the approximation to binomial distribution. Sample number 1 has minimum n1 minus p equals 2.0. This does not mean that the chart results are invalid. An obvious out or in will not likely be affected, but the results should be used with caution and if possible more data collected. As with ANOM two-way normal, which is covered in another video, for the slice charts, the basic idea is to compare the levels of one factor for each level of the other factor. Mean square error is derived from the whole model. A yellow highlight automatically recommends main effects if the interaction is not significant, or slice charts if the interaction is significant. The interaction p-value is automatically determined from logistic regression for binomial proportions. Click the Length of Stay Binomial Prop tab. This is hospital length of stay data after bypass surgery. The data is from factorial design with factors drug A and B and treatment 1, 2, and 3. Click Graphical Tools, Analysis of Means, ANOM, ANOM Binomial Proportions two-way. Select LOS, or length of stay, greater than 6 days. Click Numeric Data Variable Y. Select Sample Size, and click Subgroup Column or Size. Select Drug, and click Group Category Factor X1. Select Treatment, and click Group Category Factor X2. Ensure alpha level is equal to 0.05. And adjust chart alpha for family-wise error rate is unchecked. Click OK. Since the interaction p-value is less than 0.1, the slice charts are highlighted. The slice plot clearly shows the effect of the strong interaction. When drug is equal to A, treatment type 2 results in a significantly lower mean proportion length of stay, and treatment type 3 results in a significantly higher length of stay. When the drug is equal to B, the treatment does not have a significant effect on length of stay. This concludes the ANOM Binomial Proportions one-way and Binomial Proportions two-way tutorial video. For more videos, visit us at www.sigmaxl.com or join us at our YouTube page. Thank you for watching.